A projectile is launched from the ground with an initial velocity v naught and angle theta above the horizontal. What's the maximum height? Okay, so we can start off with, with using the second equation again in the vertical direction. So we would have y equals y naught plus v naught yt minus 1/2 gt squared. Now, since we're going vertically, we're starting at a position of 0 in the vertical direction, and we want to find out what our maximum height would be, which would be y. So let's rewrite this y, and we'll break v naught y into its vertical component, which would be v naught sine theta times time minus 1/2 gt squared. Now, to get our time, we could go back to multiple choice number 38, the time to the maximum height, which we came up with t equals v naught sine theta over g. All right, so we can plug that in for t. So y equals v naught sine theta times the time, which is v naught sine theta over g. Let's change the color here. Since we used green before for time, let's plug green in. V naught sine theta over g minus 1/2 g. And let's plug in our time again, which is v naught sine theta over g. And we need to square that. Moving forward, we would get y equals, let's multiply v naught times v naught, and we're going to get v naught squared, sine times sine, sine squared, sine squared times theta all over g, minus 1/2 g times, and let's take this out of parentheses, so it would be v naught squared sine squared theta over g squared. Okay, so we would have y equals v naught squared sine squared theta over g minus, we have g in the numerator, g squared in the denominator. We can cancel that and put 2 in the denominator, and we would have v naught squared sine squared theta over 2g. Now, if you look at this, the numerators are identical here, right? And it's over 1 over g, so over 1 and over 2g. So it's almost like saying we have y equals 1 minus 1 over 2, 1 minus a half. So 1 minus a half is going to give us a half. So that literally is going to equal v naught squared sine squared theta over 2g, which looks a whole lot like that, or the 1/2, as we're seeing here. That would correspond to C.